users, either anonymous or otherwise, are able to upload and download to the server. You may also change root based on a list. You may also allow change mods of files and or directories. You may chown uploads, meaning change ownership. So a user may upload a file, let's say as Linux CBT, but you may want the file to be saved under someone else's credentials. That's quite possible using VSFTPD. You can set up a list of email addresses, offensive email addresses to disable in the event that you publish an anonymous server and users are abusing it. If the directory messages are enabled, if there's a hidden file in a directory that a user enters, that hidden file will be processed and returned. If it's a hidden file .message, will be processed and returned to the user when the user enters that directory. Even a user's default home directory. So for example, let's open a separate shell here. We'll scroll through this first and come back to that in a moment. There's dual log support. You can log to extra log and varlog VSFTPD.log. Tells you the former extra log is in the form of Washington University's FTPD, whereas the latter is in VSFTPD's format. Again, SSL support is provided by VSFTPD, so if you want to provide an FTP secure server, you can. If listen is enabled, VSFTPD runs outside of ZynetD. If it's not set to listen, it can be controlled by ZynetD, the super server. It also supports IPv6, with the default being no. Let's SSH as root to that system, just to have another window open so we can discuss it while we look at the directives. Currently, if we netstat ntl grep21, we'll see that it's listening to IPv4. We know because it's using the address all zeros as opposed to triple colons 21. So right now it's not listening to IPv6, but it can listen to IPv6 if you indicate listen underscore IPv6 equals yes. Let's go ahead and turn that on anyway. We'll nano etc vsftpd vsftpd.conf, and we'll just search a document for IP6, and listen is set to yes for IPv4, but listen underscore IPv6 is set to off, indicated by the comment. So let's go ahead and execute service VSFTPD restart. This will cause it to listen to IPv6, and if it doesn't, it gets thrown an error in this particular case. It could be because the IPv6 address threw an error in binding, and a tail of varlog messages will return an error as to why the IPv6 interface failed, which we'll look at momentarily. So let's go ahead and just modify it again to get it started so we can continue what we were doing. We'll nano vsftpd.conf. Let's find IPv6. And here it tells us that in order to listen to IP version 4 and IPv6, you must run 2 copies of VSFTPD. And it also mentions right above that you cannot use listen equals yes with listen IPv6 equals yes, which is why we threw an error. So it's not SE Linux, rather the fact that we cannot use both directives. Now it's started. Let's netstat ntl. And if we look for port 21, we now see that it's bound to IPv4 and IPv6. So as a separate task, enable IPv6 listener. We just ensure that this is enabled, equals yes, and indicate do not use with listen equals yes, which is used for IPv4. But if you wanted to use them independently, the documentation suggests that you run 2 instances of VSFTPD. Now when you listen to IPv6, you can connect using 4. Let's go back to our local system, FTP in, ABC123 is the password, and there we're in using IPv4 that is. But if we know the IPv6 address of the server, we can use that address as well to connect. Now let's continue looking through our directives. We can log the FTP protocol, password change rule enable, pass V. This FTP server supports both passive as well as active modes. By default, passive is enabled, but both will be supported or run at the same time and supported sort of simultaneously, in that if the connecting user wants active, the server will switch to active, and if they want or request passive, then passive will work. Whether or not to turn on SSL, the versions of SSL, whether or not to log through syslog and to enable TCP wrappers, meaning the ability to control security to the system, to the FTPD system via TCP wrappers or etc hosts that allow and deny files. Whether or not write enable should be permitted. X for log, whether or not it's enabled, and it's currently set to yes. And then you've got the numeric options we were talking about earlier, which is the reason why we looked at the documentation to begin with, which includes the transfer rates for the classes of users, including anonymous and non-anonymous. So to control anonymous's transfer rate, you'd use anonymous or a non-max rate, and you'd set it to a value in bytes per second. So for 1,000 bytes per second, use 1,000. A non-max rate, 1,000. But you've also got other numeric options, such as the ability to timeout connections, connect timeout, which defaults to 60 seconds. You can set it to lower or higher to suit your needs. Idle session timeout, if you don't make any changes after having established a connection within 300 seconds or 5 minutes, the connection will terminate. And for non-anonymous users, the local max rate measured in bytes per second will restrict the transfer rate if set. So if you set local max rate equivalent to a low value, then users will be forced to move data at that low value. Let's modify etc VSFTPD.conf again. And we'll navigate towards an empty space, commented as restrict transfer rate for non-anonymous users by setting local_max_rate equal to a certain number of bytes per second, such as 1,000 bytes per second. Restart the server. Then reconnect from our local system. And then attempt to list the directory's contents and get the file linuxcbt.txt. And this will take forever and a day to transfer the file and then return the transfer rate. Now when we look at LFTP next, you'll see the transfer rate dynamically, but the reason why this is not yet complete is because it's transferring at a slow rate. So a seventh feature would be to restrict non-anonymous users' transfer rate. This is a way to control the amount of bandwidth that's dispensed or used by your FTP server. You may have a T connected to the net, or fractional T, or 100 megabits, or what have you, but want to segment or restrict the utilization per connected user. So set local_max per rate equal, let's say, 1,000. Restricts connections to 1,000 bytes per second, or roughly 1K per second. As indicated in the man page for the configuration file, VSFTPD-conf. And again, that's the local transfer rate in bytes per second. So if you set it to 1,000, then that's 1,000 bytes, or 1K per second. And this is again for local authenticated users. You may set a UMask for the local user independent of the anonymous user. Maximum login failure attempts. If the default is 3 and it works with your environment, your security policy, then no need to indicate it, but if it's lower or higher, adjust it accordingly. Maximum number of connections per IP, per source IP. Currently it's by default it's unlimited, but you can indicate whatever suits your environment again. Again, VSFTPD is highly configurable. We could easily spend 2, 3, 4 hours or more focusing on this one application alone. But we've shown you how to set it up, how to circumvent or bypass SE Linux to ensure that users can access their home directories, how to disable anonymous, how to set transfer rates, and to test it by trying to download something which is still downloading, and how to enable various options. But there are many other options such as message files, banner files, you name it, for connecting. It's a highly configurable file transfer protocol daemon server included with Red Hat Enterprise Linux, but not installed by default. And now you know how to set it up and get some basic settings going. Next, we'll look at LFTP, which is a file transfer protocol client.